Well, welcome back to another exciting night in Common Core Algebra 2. Our goal tonight is to, as you can see here, factor the sum and difference of two perfect cubes. So you can say we've graduated from our perfect squares into a little upper level math of perfect cubes. But before we get started, we want to hit you with another field in mathematics called actuarial science. This is a very hot field these days, and it is associated with a lot of money. Over the past few years, we've had several students get into the actuarial science field and have been able to find really solid jobs and are financially well off. Basically, what it boils down to is you are in charge of measuring risk. Whether you work for a finance company or an insurance company. In fact, actuarial science has even spread into sports or athletics. And you might have heard of the term analytics. And basically they're measuring risk and making trades based off that. So just like a perfect square are two of the same numbers times each other, a perfect cube would be three of the same numbers multiplied together. So for example, 1 cubed is really equal to 1 times 1 times 1, which is 1. So 1 is our first perfect cube. 2 cubed is really 2 times 2 times 2. Now you don't need a calculator. 2 times 2 is 4, times 2 is 8. Okay, so you should be listing these out in your notebook. 3 cubed is really 3 times 3 times 3. Again, probably don't need a calculator. 3 times 3 is 9, times 3 is 27. 4 cubed, it really is just 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. 5 cubed is 5 times 5 times 5. So 5 times 5 is 25, times another 5 is 125. We'll go 6 cubed. Of course, is just 6 times 6 times 6, which is 216. And let's go ahead and squeeze one more in there that we should probably know up through. 7 cubed is 7 times 7 times 7, which is 343. Now obviously these are going to go on to infinity. You just take any three of the same numbers and multiply them and you get a perfect cube. So what I want you to do is box in this side, and these are the perfect cubes that you should know or to be able to get to pretty quickly. The more you have these memorized and recognized, the easier your math will be. Another big feature we have to pull out is that algebraic expressions can also be perfect cubes. So what do I mean by that? Well, x cubed is a perfect cube because it's x times x times x. Remember, it has to be three of the exact same things being multiplied, which gets me x cubed. So there's my first perfect cube. I could take x squared and cube it, which really means take x squared and multiply itself 3 times. Okay, now let's think back to some basic rules. When I multiply, what do I do with the exponents? Well, of course, when you're multiplying, you add exponents. That's 2, 4, 6. So I get x to the 6 is a perfect cube. I could say x cubed cubed, which is really x cubed times x cubed times x cubed. So again, I'm multiplying, so I'm going to add the exponents. 3 plus 3 plus 3 gets me x to the 9th. And we'll stick one more in there, x to the 4th cubed. So x to the 4th times x to the 4th times x to the 4th. 4 plus 4 plus 4 gets me x to the 12th. Now we've got a nice little list developing here, and I'm going to cheat a little. I'm not going to write them all out. I'm going to hope you can help me figure out what the next perfect cube would be. Notice I had x cubed to x to the 6th, x to the 9th, x to the 12th. Can you figure out what the next one would be? X to the 15, x to the 18, x to the 21st. Hopefully you're starting to see that pattern, that because it's a perfect cube and we started with x cubed, we're going with multiples of 3. So our goal is to focus on the sum of perfect cubes and the difference of perfect cubes. So you can go ahead and put this in your notebook. I'll draw a little line dividing between the two. The sum of perfect cubes would be x cubed plus 8. And I'm hoping it's obvious when I say sum because I see a plus sign. And I know they're perfect cubes because x cubed is x times x times x, and 8 is really 2 times 2 times 2. And again, hence sum just means you're going to see a plus sign. Likewise, the difference of two perfect cubes would be x cubed minus 8. Instead of seeing the plus, I now see a difference, which is a minus sign. And again, this is a perfect cube because of the x times x times x, and 8 is a perfect cube because of the 2 times 2 times 2. All right, well, grab that highlighter because these are the rules that we have to remember for tonight. Now, they're not given to you on a formula sheet or anything like that. We do have to memorize these, and they're going to look a little intimidating at first, but we're going to talk you through them, and hopefully you'll feel pretty confident with them by the end of this lesson. So the sum of two cubes is going to look like a cubed plus b cubed, okay, equals, and here's where, pay close attention here, a plus b times the quantity, a squared, minus ab plus b squared. Whew. And you might be thinking, how the heck am I going to remember that? Well, we're going to try to give you some tools in the next few minutes to do that. So let me throw the difference of two cubes at you. I'm going to say that's a cubed minus b cubed equals the quantity a minus b times a squared plus ab plus b squared. Okay, so there's a couple things that we should notice right off the bat. When we said sum of two cubes, notice this was a plus sign. And when we said the quantity a plus b, notice it was also a plus sign for sum of two cubes. When we said difference of two cubes, notice there was a minus here, and this quantity was a minus b. So those always stay the same. So there's one hint that's easy to remember. The other thing that I noticed right off the bat is this last term is always positive. It didn't matter which one it was always positive. The a was always positive. It was just this term that changed. So we have a little saying that will hopefully help you remember these rules, and it's called SOAP. So let's go ahead and write that acronym down, and I'll tell you what it stands for. S stands for same, and then we're going to say opposite, and then always positive. Okay, so same, opposite, always positive. So again, what am I talking about? And let's go ahead and take your pen or your highlighter and make a note here. Same. This sign and this sign will always be the same. Okay, so mark it down in both pictures. Opposite. This sign here, and you can maybe box it in for yourself, will be opposite of whatever the original question is. So if this is a plus, then your AB is going to be negative. If it's a minus, the opposite would be a positive. Okay, so it's same, opposite, and now always positive is that last term, and I'll put a triangle around it. That's always a positive value. Now, here's the other trick I always want to make sure we do, and again, most importantly, let's get this in your notebook and highlighted. You always want to identify who's being cubed as A and who's being cubed as B. Okay, we always have to figure out who A and B are before we can do anything. And we're going to run through some examples and really try to make you feel confident in this idea. All right, let's tackle this first question together. Factor x cubed minus 27. All right, so I'm going to run through what goes through my head first. I'm going to look for a GCF. Do they have anything in common? No, that's out. Are they perfect squares? That's out. Are they perfect cubes? Looks like it. So what are my goals? The first thing I want to do is identify who A is and who B is. So A is, let's make a note, A is the first term that you're going to cube, and B is the second term that you're going to cube. Okay, so the question is, who am I cubing to get x cubed? So cubing means you're going to multiply it 3 times. Who are you multiplying by to get x cubed? And that will tell you who A is. So I want you to write this out in your notebook. What times what times what is x cubed? Well, hopefully you're saying it's x times x times x. Therefore, dot, 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 your A value is equal to x. Okay, let's get the second term. I see a 27. So what times what times what is equal to 27? Now notice I didn't write down negative 27, and this is huge, so we probably need to pause it and put this in our notebook. This minus sign does not mean the 27 is negative. All it implies is that it's a difference of perfect cubes instead of a sum of perfect cubes. Okay, so again, pause it and write that in your notebook. Nothing is negative. This just means it's a difference of perfect cubes instead of a sum. So what times what times what is 27? Well, all you got to do is start the beginning of the numbers. Is it 1 times 1 times 1? Of course not. How about 2 times 2 times 2? Well, let's check. 2 times 2 is 4, times 2 is 8. Well, that's not 27. How about 3 times 3 times 3? Well, 3 times 3 is 9, times 3 is 27. There we go. Therefore, your B value must be 3. Now, once you've identified A and B, this really isn't that hard. Okay, the hardest part is just saying who's A and who's B. So now we got to memorize that formula, and I'm going to try to do it without you having to look back at your formula sheet already or out your notes. So let's say it's A cubed minus B cubed, because it was the difference of perfect cubes. Okay, now it's just either A plus B or A minus B, and the SOAP acronym said to keep it the same sign. So it's A minus B. So I'm keeping just my A and my B. SOAP, same, says keep this the same sign. Times the quantity. You take the first term, which is A, and you square it. Okay, so I took this term and I squared it. Okay, now I take the A and the B and I multiply them together. And remember, this is the opposite sign. That's what the O in SOAP stands for, so that's a plus. And always positive means make the last term positive, and now you take the last term and you square it. And it's that simple. So again, let me talk about where it came from again. A minus B, because it's a difference of two perfect cubes. You maybe make a little note here for yourself, an arrow. You take the first term and you square it. Then you take these two together and you multiply them, and then you take the last term and you square it. And that's all it is. Now we'll throw in the A and the B in the formula. So this is going to be x cubed minus 27 equals, okay, so I'm going to put in my A is x minus my B is 3. Now, here's the catch. When you substitute, okay, I want to make sure that you're putting things in parentheses. So I'm going to say this is x squared plus x times 3, notice I'm substituting, I'm using parentheses, plus 3 squared. Everything you substitute in gets parentheses. Now we'll just go through and clean up the math behind it. So this equals x minus 3, okay? When I take an x and square it, I get x squared. Keep my plus sign, x times a 3, we just put the number first, 3x, plus, and 3 squared is 9. And I'm going to really encourage you to do it in 2 steps because it can get ugly. So make sure you substitute with parentheses and then write it out. All right, let's make it a little more interesting. 27x cubed minus 8y to the 15th. So again, I know it's a difference of two perfect cubes because of the minus sign. So I'm going to start with my formula. And so it's going to be a cubed minus b cubed equals a minus b. So again, I'm just practicing saying the formula out loud to myself. Times that first term squared, a squared. Take these two and multiply, an opposite sign, so plus ab. And then the last term is always positive, and we'll square the b. Alright, so the big question is, none of this works until you identify who A and B are. So that's my first goal. Who is A? What times what times what is going to get me a 27x cubed? Okay? So again, I'm just going to go through the numbers. 1 times 1 times 1, not 27. 2 times 2 times 2, hopefully you know that's 8. 3 times 3 is 9, times 3 is 27. So I know it has to be a 3 something. And what times what times what is x cubed? Well, that would make 3x. Therefore, my A value is 3x. Let's do the same with the B value. What times what times what is 8y to the 15th. Okay, so let's start number-wise. Hopefully, you're going 2 times 2 times 2. Gets you 8. Now, y to the 15th is going to be y to the what power gets me y to the 15th? Well, if it's the first, that makes 1, 2, 3. That's not 15. If it's 2, that's 2, 4, 6, because when I multiply, I add exponents. If it's 3, 3, 6, 9, that's not 15. 4, 8, 12, 5, 10, 15. So hopefully you're saying it's 2y to the 5th. So I'm going to say my B value is 2y to the 5th. All right, so now I just need to throw them into this formula, so to speak. So, I'm kind of draw a line here, grab a different color. This is the formula I'm throwing them into. So my a value is, who did we say, 3x, and my b value is 2y to the 5th. So I'm going to say this equals 27x cubed minus 8y to the 15th, okay, equals, so a minus b, so that's 3x minus 2y to the 5th times, okay, so I'm going to use my bracket and substitute with parentheses. That a term squared, so that's 3 quantity x squared, opposite, so plus, I need the a term times the b term, so that's 3x times 2y to the 5th, always positive. Now take that b term, 2y to the 5th, and square it. Alright, and now I'm just going to clean that up. Obviously that's the important part. So I have 3x minus 2y to the 5th times, when I square the 3, I get a 9, and when I square the x, I get x squared. Multiply these, so I'm going to say that's plus 6xy to the 5th, always positive. Square the 2, I get a 4. Remember, y to the 5th times y to the 5th, when I multiply, add those, and I get y to the 10th. And there you have it. There is our difference of those two perfect cubes. All right, our next one says factor 2a to the 9th minus 432. Oh man, you might be nervous with that large number. Well, let's go ahead and make a note here. You'll notice I've said it every time. I'm always looking for a what first? GCF. Okay, always, always, always check for a GCF first, because that will make your life much easier. And I notice they're both even, which means I can pull out a 2. So I'm going to pull out a 2. And then I get a to the 9th minus 216. Now, why is that a lot nicer? Well, this is divisible by 3, so I know that's a perfect cube. And 216, I know in my head is a perfect cube, so I have the difference of two perfect cubes. So again, my goal is to say who is A and who is B. And I feel like I've really drawn that out enough for you tonight that you should be able to come up with who A is and who B is. Now remember, nobody's negative. So don't tell me any of these are negative. This just tells you to use the difference formula. So why don't you pause it, take a few seconds, and figure out who A and B are. Well, hopefully you'll agree with me. I have my A to be, oops, I should use a capital A. My A is A cubed, and my B I had is 6. And again, I just said, is it A times A times A? No, that makes A to the 3rd, and then I just went through and figured out who my exponent should be. But I've identified my A and my B, so this should be pretty straightforward. It is a difference of two perfect cubes. So I'm going to start with my formula. A cubed minus B cubed equals, again, A minus B, same sign. Square the first term, A squared, opposite, multiply the middle 2, always positive, and square that guy. So I'm just going to carefully substitute these in. So I'm going to say this is A cubed minus 6 times parentheses a cubed squared plus a cubed times 6 plus 6 squared. And then my last step, of course, is to clean it up. So I've got a cubed minus 6 times the quantity. A cubed times itself is really a to the 6 plus 6a cubed plus 36. All right, thought I'd throw one more at you just for fun here. I just enjoy factoring so much. Hopefully you're enjoying it as well. Now again, these are hideous. Right off the bat, I know 8 is not a perfect cube or a perfect square. Those numbers don't look familiar, so I have to pull out a GCF. And guys, I'm not starting high when I think GCF. I start by trying a 2, then a 3, then a 4. I always start at the very, very low end of the numbers. Just grab your calculator, see if they both divide by 2 evenly. If they don't, try dividing them both by 3. So in fact, I can pull out a 3. And you'll notice I can also pull out variables this time. Here's an x to the 8th and an x squared, so I can take out an x squared. And I am left with 64x to the 6th plus 125y cubed. Okay, that GCF is huge. Make sure you are pulling that out first. And I'm going to kind of speed up the process here, and hopefully you're feeling okay with this. My goal is to identify that A and the B, remember. Who am I cubing to get 64x to the 6th? Who am I cubing to get 125y cubed? Okay, and again, once you have that, it's pretty simple. So what times what is 64? Again, is it 1 times 1 times 1, 2 times 2 times 2? Hopefully, you've got it as 4. And I'm going to say that's x squared. X squared, x squared, x squared gives me x to the 6th. Here I'm going to go with 5y. And then, again, I'm just going to throw them in the formula. This was a sum, I believe, of perfect cubes. Yep, sum right there. So, this time, remember we have that GCF out front. So I got to make sure I leave that out front. So I'm going to say it's 3x squared times a plus b times a squared minus ab plus b squared. Okay, and I'll just carefully plug them in. So 3x squared times 4x squared plus 5y times, parentheses, 4x squared squared minus 4x squared times 5y plus 5y squared, bracket that in. And again, just a little plug and chug. Hopefully you're kind of working it out ahead of me. That would be fantastic. 4x squared plus 5y times, what's that going to give me? 16x to the 4th plus 20x squared y plus 25y squared. And there you have it. Well, that does it for us tonight. We've got a lot of practice for tomorrow, and we look forward to working with you. Have a great night.